For today's video, we will answer a math challenge given by one of our followers. And the question goes like this. Given this equation, e raised to the power of x minus e raised to the power of 2x equals 1, then our goal is to solve for all possible values of x. Now you can pause this video if you want to give this problem a try. Now suppose you pause this video. Now let's see if you get the correct answer. Alright, so the value of x in this question is not a real number. X here is a complex number. So now, how are we going to answer this kind of question? First, let's get the equation that we want to solve, and let's focus on this term, e raised to the power of 2 times x. Now, using some laws of exponent, take note, when we have b raised to the power of a times c, it can be written as b raised to the power of a raised to the power of c. So, e raised to the power of 2 times x, we can rewrite this as e raised to the power of x raised to the power of 2. Now, the question is why we do that. Because now we have a common term of e raised to the power of x. Now, at this point, since we have same term, what we're going to do is to replace this with another variable, and let's call this as t. So, let t be equal to e raised to the power of x. Now, all of this e raised to the power of x, we can replace this with the variable t, like this. And now, it looks like a quadratic equation in terms of t. Now, what we're going to do is to rearrange some terms a little bit, and let's equate this to 0. So, we have 0 equals t squared minus t plus 1. And I will tell you that this quadratic equation is not factorable, so what we're going to do is to use the quadratic formula. So, we have negative b plus or minus square root of b squared minus 4ac all over 2a. And what is a in this formula? The a is the coefficient of t squared, which is 1. This b is the coefficient of t, which is negative 1. And c is the constant term, which is again positive 1. Now, let's replace all of those variables. So, all a becomes 1. Now, replace all b with negative 1, like this. And the c with positive 1. Now, let's simplify. Negative of negative 1, this is just positive 1. And the negative 1 raised to the power of 2, this is just positive 1. And the 1 minus 4 is negative 3. Now, what is the value of square root of negative 3? Take note, negative 3, we can write this as negative 1 times 3. And we can split this into square root of negative 1 multiplied by square root of 3. Now, by definition, square root of negative 1 is I. So, we have t equals 1 plus or minus I multiplied by square root of 3 all over 2. This is the value of t, but we don't want the value of t. We want the value of x. And we know also that t is e raised to the power of x. So we can say that e raised to the power of x must be equal to 1 plus or minus I multiplied by square root of 3 all over 2. Now at this point, to solve for the value of this variable x, what we're going to do is to take the natural log on both sides. Because we will use some properties of natural log. So take note, when we have ln of b raised to the power of a, we can pull out this exponent a and pull this exponent in the front. So we have a multiplied by ln of b. So the left-hand side of our equation, we can rewrite this as x multiplied by ln of e. Now, another property of natural log is ln of e must be equal to 1 because the base here is also e. So, this ln e is just 1, so x times 1 is just x. And that is the value of x, which is ln of 1 plus or minus I multiplied by square root of 3 all over 2. And that is the value of x that satisfies this equation. Although it is complex number, but still, this value will satisfy this entire equation. And as always, we are done.